Many students are daunted by the task of passing Leaving Cert Maths. In the 2022 exam, nearly 2,000 students failed ordinary level maths. If you want to avoid this fate, or you're simply looking to pick up some easy marks to boost your grade, then you've come to the right place. The focus here is on Paper 1 of the 2022 Ordinary Level exam. To pass this paper, a grade of 40% had to be obtained. So, how much course knowledge is actually required to achieve this grade? And how much time is needed? Well, it's reasonable to assume that you would need to understand 40% of the syllabus and use 40% of the allocated time. Surprisingly, this is far from the truth. The official Leaving Cert syllabus lists 49 different mathematical skills that are relevant for Paper 1. It was possible to pass this paper using only 7 of these. In other words, knowledge of 14% of the syllabus was enough to pass the paper. If you stick around until later in the video, I'll show you exactly what these 7 key skills are. And the best part about this is that these 7 skills are regarded as some of the easiest on the whole syllabus. The exam had a duration of 2 hours and 30 minutes. In this video, I'll walk you through step-by-step solutions of the questions needed to achieve a target grade of 40%. All of this is done in less than 18.5 minutes, which is roughly 12% of the allocated time. The remainder of the video is structured as follows. I'll begin by breaking down the official marking scheme for the exam and identifying the easiest questions to answer to reach a passing grade. Then, I'll provide detailed work solutions to these questions. Finally, I'll summarise the 7 key skills which were used to achieve this golden target of 40%. Many of these skills come up every single year in the Leaving Cert, and mastering them can go a long way in boosting your chances at a higher grade. Paper 1 on the 2022 Ordinary Level Maths exam was split into 2 sections, Section A and Section B. Section A contained 6 questions and you needed to answer 4 of these. Each question was worth 30 marks, so in total, Section A was worth 120 marks. Section B contained 4 questions, and you had to answer 2. Each question was worth 50 marks, meaning that Section B was worth 100 marks in total. There's many ways you could have selected which questions you wanted to answer. However, there were several places where it was particularly easy to pick up marks, and I'll show you exactly where these places were. In Section A, Question 1, A and B were worth 15 marks. Question 2A was worth 10 marks. Question 4, AI, was worth 10 marks. And Question 5, C, I and II were worth 10 marks. Each of these questions gave a large number of marks when you consider the amount of work and knowledge required to solve them. Moving to Section B, answering Question 7, Parts A, B and C gave a total of 30 marks. Answering Question 10, AI, AII and CI gave a further 15 marks. Each of these highlighted questions gave you very good bang for your buck. You didn't need much knowledge or time to solve these questions, but you got rewarded with a lot of marks for your efforts. If you did manage to solve all these highlighted questions, you would have ended up with 45 marks on Section A and 45 marks on Section B. In total, this would have given you 90 marks out of 220, which would give you a final grade of 40.9%. In other words, if you answered these highlighted questions, it would have been enough to pass the paper. So, how hard was it to solve these questions? Well, in the next section of the video, I'll walk you through step-by-step solutions for each of these, and you might be pleasantly surprised at how easy it is. Question 1, A and B, combined for a total of 15 marks. To pick up these marks, all we need to know is how to plot complex numbers. In our diagram, there's a point labelled as Z1. Our first task is to write down the value of Z1. To do this, we should identify its coordinates. Z1 has a value of -2 on the horizontal real axis. It has a value of -3 on the vertical imaginary axis. This represents the I component of our complex number, so we can think of this as -3i. So, what's the value of Z1? It's simply -2 minus 3i. Our next task is to find Z1 bar, the complex conjugate of Z1. To find a conjugate, all we have to do is change the sign of the I component. Z1 was -2 minus 3i, so the conjugate will be -2 plus 3i. Now that we found our complex conjugate, we must plot and label it on our diagram. Well, our number has a real component of -2 and an imaginary component of +3. So all we have to do is go to -2 on the real axis and +3 on the imaginary axis and plot a point right there. In part B, we must plot and label two other complex numbers. Z2 has a real component of -5 and an imaginary component of +3. So we go to -5 on the real axis and +3 on the imaginary axis and plot a point at their intersection. Z3 has a real component of 4 and an imaginary component of -2. So that would appear right here. Question 2a was worth 10 marks and involved solving a linear equation. The first step here would be to multiply out the brackets on our left-hand side. 2 times 3x gives us 6x, and 2 times -5 gives us -10. From here, we can do some simplification on the left-hand side. -10 plus 8 is -2. The resulting equation contains two x terms, 6x and 4x, and two number terms, -2 and -5. The strategy here will be to group all the x terms on one side of the equation and all the number terms on the other side. Here, I'll group my x terms on the left and my number terms on the right. We can remove the 4x from the right-hand side by subtracting 4x from both sides. We can remove the -2 from the left by adding 2 to both sides. Now let's simplify. 6x minus 4x is 2x. -5 plus 2 is -3. So we end up with 2x is equal to -3. The final step is to remove the 2 which is in front of the x. This 2 represents multiplication, so to get rid of it we need to do the opposite, division. Dividing both sides by 2 brings us to our final answer, that x is equal to -3/2. Question 4a was worth 10 marks and involved subbing in a value into a function. These were probably the easiest 10 marks on the whole paper. We are presented with a function, g of x, and then asked to work out the value of g of 5. To find this, all we have to do is sub in x equal to 5 into our expression. In other words, we replace every x with a 5. This gives us 5 cubed minus 7 times 5 squared plus 5 minus 12. Typing this into our calculator gives us the value of g of 5. It's -57. Question 5c was worth 10 marks and involves interpreting a function graph. Our diagram contains two curves. Y is equal to m of x and y is equal to k of x. Our first task is to find two values where m of x is equal to 0. Looking at our vertical y-axis, 0 appears here. So, the points where m of x is equal to 0 will be here and here. To get our answers, we just need to read off the x values of these points. The first one is quite straightforward, it's x is equal to 1. The second point appears to be exactly halfway between 4 and 5. So this would be x is equal to 4.5. In part 2, we must find the range of values of x for which our red function, k of x, is less than our blue function, m of x. In other words, we need to find the region where the red line, k of x, is below the blue line, m of x. Well, looking at our diagram, in most places the red line is above the blue line. The only region where the red line is lower is right here. To get our answer, we simply need to specify the x values for this range. Well, it starts at 2 and it ends at 3.5. So our answer here is between x equals to 2 and x equals to 3.5. Question 7a was worth 15 marks and involved completing a function table and drawing a graph. In this question, h of x represents the heart rate and x represents the time in minutes. The top row of our table lists several time values. In the second row, we want to find the heart rate at these times. To fill in the blanks, all we have to do is sub in the relevant x values into our function, h of x. The first blank occurs at a time of 0 minutes. To fill this in, all we have to do is sub in x is equal to 0 into our function. Using our calculator to perform this calculation, we get an answer of 158. The next blank occurs at a time of 2 minutes. So here, let's sub in x is equal to 2. When we type this into our calculator, we'll get 165.1. The question wants us to write our numbers correct to the nearest whole number, so we'll round this off to 165. The next blank is at a time of 4 minutes, so we should sub in x equal to 4. This time, our calculator will give us an answer of 174.76. Rounded to the nearest whole number, this will be 175. The final blank occurs at a time of 5 minutes. So here we'll sub in x equal to 5 into our function. Our calculator will give us an answer of 174.85, which rounded to the nearest whole number is 175. In the next part of the question, we need to draw a graph of our function. To begin, we should plot each of the pairs that we have in our table. Our first pair has a time of 0 and a heart rate of 158. Well, a time of 0 is here, and a heart rate of 158 is here. So this will be our point. The next pair has a time of 1 and a heart rate of 160. So the point will go right here. In the next pair, we've a time of 2 and a heart rate of 165. So this point will appear here. Next, we've a time of 3 and a heart rate of 171. That gives us a point right here. Then we've a time of 4 and a heart rate of 175. That point will be plotted here. Finally, we have a time of 5 and a heart rate of 175. That gives a point here. The final point, 6169, has already been plotted for us. To finish our graph, we should join our points with a smooth curve. So we'll end up with something like this. Continuing with question 7, part B was worth 5 marks and part C was worth 10 marks. These questions involved interpreting and extending a graph. In part B, we must explain what the coordinates 6, 1, 6, 9 represent. Well, looking at our axis labels, the 6 is representing the time in minutes. The 169 is representing a heart rate in BPM. So the interpretation is straightforward. After 6 minutes, Joseph's heart rate was 169 BPM. In a previous part of the question, we drew our graph in the range of 0 minutes to 6 minutes. In part C, we need to use the given information to extend this further. We're told that Joseph's heart rate stays at the same level for the next 2 minutes. Well, at 6 minutes he had a heart rate of 169. If it stays the same for the next 2 minutes, that means that at 7 minutes he'll also have a heart rate of 169, and at 8 minutes he'll still have a heart rate of 169. Then, his heart rate decreases at a steady rate of 10 BPM per minute for the next 2 minutes. Well, at 8 minutes his BPM is 169. So at 9 minutes, this will have dropped 10 to 159. At 10 minutes, it will drop another 10 to 149. In question 10, parts A, I, and II were both worth 5 marks. Part C, I was also worth 5 marks. To solve these questions, we need to be able to sub into a function and perform a basic percentage calculation. In the question here, h represents the height of the ball, and t represents the time in seconds. In part A, I, we need to find the height when t is equal to 0. The function that we're given tells us the height at any given time. So to solve this, all we have to do is sub in t equal to 0 into our function. This gives us h is equal to minus 2 times 0 squared, plus 5 times 0, plus 1.2. Doing this in our calculator gives us our answer of 1.2 meters. In the next part, we're told that the ball was caught after a time of t equals 2.4 seconds. The height when the ball was caught will simply be whatever the height was at 2.4 seconds. To find this, we simply need to sub in t equals 2.4 into our function. This gives us minus 2 times 2.4 squared plus 5 times 2.4 plus 1.2. Typing this into our calculator gives us our answer, 1.68 meters. Part CI involves a percentage calculation. Keith is getting a discount of 15% on an item which usually costs €33. Well, if we're getting a 15% discount, this means we'll be paying 85% of the full price. To find our answer, we simply need to take the original price, €33, and multiply it by 85%. This gives us an answer of €28.05. To conclude this video, I'll summarise the 7 key skills we used to acquire enough marks to pass our paper. The first skill was illustrating complex numbers on an Argand diagram, and this earned us 10 marks. The second skill was being able to calculate the complex conjugate, and this earned us 5 marks. Performing a percentage calculation got us 5 marks. Solving linear equations earned us 10 marks. Evaluating a function got us 27 marks. Graphing a function got us 18 marks. And interpreting graphs got us 15 marks. In particular, I'd like to draw your attention to the final 3 skills here: evaluating a function, graphing a function, and interpreting graphs. Together, these combined for a massive 60 marks. If you master these 3 skills, it could go a long way in boosting your Leaving Cert grade.